Okay, this video is for people who's just completely stuck in the setup of the problem. One part of the reason this problem is unclear is because what is C and what is D? C is defined to be the minimum of max separations, and D is the max of min separations. What does that mean? There's so many mins and maxes, so why don't we create an example to get a sense of what these quantities C and D really represent. I'll create a simple graph. Okay, let's calculate what C and D would be for this simple graph. To calculate C and D, we need to have, well, obviously the oops, I made a typo here. Max separations. We need to calculate max separations. So we do it for A. What's the max separation for A? Well, A is furthest away from D, and they're separated by a path of length 2. So max separation is 2. For B, it's the same thing. It's further away from D, and you get there with a path of length 2. Trivial. C is interesting because, you know, it can get to any node with a path of length 1. So, in fact, for C, max separation is 1. That's interesting. And D is 2. Okay, so what is C? C is just the minimum amongst these group of numbers. It's a minimum of the max separations. So it's just, boom, this is C. And D is just a maximum, which is 2. D is equal to 2. There are many maximums in this case. Okay. So that's what they really mean, in case you were confused. Okay, now we have a slight intuition. Here's the hints that they gave out in office hours, which is for any general connected graph, and we have to make a general now. There'll be many nodes, right? Many nodes. But they're connected somehow, right? It's a mess, frankly. But let's focus on what's important here. In the graph, there will be 2 nodes whose separation is the max separation in the entire graph, right? Someone ought to have the maximum separation, right? So separation is D. Let's call these nodes A and then X. All right. The hint they gave out in office hours is, because this is a connected graph, there must also be a path going from A to C. And there also is a path from C to X. In other words, there's a direct path, direct shortest path from A to X, which is of length D, and there's an indirect path from A to X, which is of length A to C plus C to X. Now, I think I've given you enough. Try to solve it. Try to see what you can come up with.